Hi everyone, this is Josh, and today we're going to do something special. Over here, above up here, I have my good friend York, who you might know from his Medium blog. Do you want to give yourself a quick introduction, York?
Hello, everyone. I'm York. You may know me from my Medium, as Josh mentioned. That's where I talk about different tech and a lot about distributed system design.
And of course, I have links to York's Medium blog in the description below. So let's get started with today's content. So York, what are we doing today?
Today, I'm joining you, Josh, in a reaction discussion into this Solana whitepaper. And if you haven't already, you should check out this video to get the full context.
All right, thanks for the plug, York. So if that being said, ready to get started?
Yep, let's go.
Right, let's go. Talking to our longtime friend, our local Cardano show and crypto expert, Scott. So Scott, why did you invest in crypto and get me into this?
Well, Josh, back in 2017, I was a young man with hope and pride. Of course, I would like to invest in the technology, and the technology would make the price goes up.
Well, this crypto expert, huh? How's he doing now?
I don't know. He doesn't really want to talk to me anymore. He seems kind of depressed ever since I told him to hodl when Bitcoin was at $70,000.
Oh, where is it now?
I think it recently hit back up to 17,000.
Crypto expert, huh?
Yep. So, as you can clearly see, we're all clueless and really have no idea what we invested in. Huh? So I thought,
Yeah.
as you see, here's a basic diagram of how Solana works. What the red arrows are pointing to, we have the transaction that users are sending to our Solana cluster. So every cluster has a leader node. These are the nodes that our users talk to do the proof of history. More on that later. And what these leader node does is that they generate these hashes, but we'll just call them transactions for now. And so what the leader node does is it generates these blocks in this picture of hashes, which are the transactions. And these combined together form a block. And then once you have these blocks, the verifier nodes will actually check to ensure that whatever the leader node is generating is actually a valid block, is not some sort of malicious block. And then once the verifier has verified that the block is correct, they send the end state of that verification. More on that as we continue. And then once the verifier nodes are finished validating through the whole block, all of the transaction hashes you see over here, it will have a final end state, which then it will send back to the leader, which will decide to commit this block to the ledger or not.
Yeah, so the first thing that we see is this network diagram. This seems like it's pretty simplified, but it does look like there's only a single leader here. So if that does go down, there's going to be some downtime until that new leader or another leader comes up to take its role. I don't know if there's an SLA or leader election timeout, but that's definitely going to delay the verification process of your transactions.
Yeah, so that's something I didn't really touch too much on in this video, but like you said, but Solana uses a leader schedule system for an epoch, which, by the way, consists of 432,000 slots, and each slot has a designated leader. And the way that this schedule is generated is that it's generated ahead of time, so all nodes will know which block will be producing, which node will be producing a block at which slot. And each slot is actually pretty short, if I recall correctly. So to answer your question, in case of a leadership failure, I would imagine worst case scenario, we just lose that block.
Cool. This area also looks like it batches transactions. That's really good for helping reduce network calls and saving bandwidth, especially since this is a distributed system, right? So you'd have to take a lot of network calls to communicate all the different transactions. So setting them all in together makes it much easier network-wise. And I also see from the diagram there's a lot of verifiers, and that's great for helping share the workload and as well as double checking the transactions are legit and confirms them, especially when there's potential malicious activity. The other thing is the verifiers will also send back votes to confirm the state, and that's something that's pretty standard for distributed databases to ensure that there's enough nodes that agree with the decision for the quorum before a set of nodes go down, and that's great for data consistency.
Yeah. So for the user, you mentioned quorum. What's a quorum? And do you see like what sort of real world examples do you know that actually uses this for distributed systems?
Yeah, so quorum is a defined amount of votes to make a transaction in question valid. So, for example, when you have a bunch of people in a room and you want to take a vote on something, usually what happens is when a certain number of votes are met, then everyone agrees that is the decision for the group. So that's in human cases, usually it's majority. For machines, we generally like to define a majority, which is n+1 over 2 nodes, have to agree for it to be valid. And many technologies in the distributed system space have a core mechanism to reach this sort of consensus. An example of a software system that does that is Zookeeper. It basically allows a lot of nodes to register themselves with the service, maintain the number of nodes to interact, and it will help maintain the quorum. There's also a variety of algorithms to reach quorum consensus, and that would be something like Paxos or Raft.
Gotcha. Thanks for the explanation. So I heard some keywords like Zookeeper, Paxos, and Raft. If you guys are all curious about what that is, I do recommend checking out York's Medium, which I'm sure he will or will eventually talk about these topics once again in the description below. Another thing I want to mention is I think I'll talk about this further in the video, but regarding majority, for proof of stake systems, we also have a majority where instead of going for a n+1 over 2 solution, Solana actually has a 2/3 majority to be able to reach consensus on anything. But I'm sure we'll get there, so let's just continue going through the video. And that roughly on the high level is how Solana works. I'm going to go into a lot more details of this whole entire process. Our leader schedule is that we take all of the verifier nodes that are actively verifying the transactions, and these nodes would be set into an active set. And then from this active set of nodes, we would sort it by the nodes that have the greatest amount of SOL staked into it. And then from there, the leader node would generate an arbitrary seed, and this seed is used to arbitrarily pick and assign the nodes in a certain epoch.
Yeah, so now that we're taking a look at leader election, the leader is based on SOL stake. The more stake you have, the more likely you will be the leader. This seems to allow the ones who control the most to have the power to basically choose transactions.
Yeah, exactly. So just out of curiosity, any examples you can think of outside the whole crypto world that does something like this?
Nothing comes to mind. Things like this tend to be solely in control of like a centralized set of entities. So I think that's one of the things that makes crypto unique right now. This also is like a pretty powerful role that can be alleviated with the verifiers generating the stake. This, I think, creates some sort of fairness where the smaller stakes are able to catch up while the leader directs, so that it has some eventually the ability to potentially become the leader themselves.
Yeah, that's a good point that you brought up that I wasn't really brought up on how nodes are distributed. And originally, I was thinking that it might be just distributed uniformly, but unfortunately, I don't really know, and I never really found any documentation about how that works. But what you said makes sense.
Yeah, one of the things here that isn't clear is how the nodes discover each other and how they ensure the communication between awesome members are being met, and not just a subset.
Yeah, that's a good question. I actually don't know how network discovery works. I do know there's a lot of instructions on how you would create a network of a validator node, and you can set it up to a network. But I don't know if there's like a centralized solution or some other way for that node to be discovered by any other existing validator nodes. Any ideas on how other distributed systems do it?
Yeah, there are different types of protocols. I would say since the Solana seems to be more of a decentralized authority, I would lean heavily towards one of the gossip protocols where one of the nodes can, when it comes up, broadcast itself to everyone and try to establish communication with everyone else. This is probably also why leaders need to slash malicious nodes so that those ones can be removed from the network. That's also more for this decentralized type. There's also other mechanisms for more centralized systems. Any chance you know how clients are routed to the leader node?
Yeah, no idea. I can imagine two ways. I imagine maybe on the app side, we have a client library that all Solana developers use that would know which validator node to talk to based off of what epoch we're on and what schedule we are on. And then if that is incorrect, another possible solution is that it doesn't matter where we send the transaction to the node, because each node has that leader schedule. They know where to redirect the transaction to, or which leader to direct the transaction to. But yeah, I don't know. And I guess another problem is that we actually rely on you trusting that node to redirect the transaction.
Right. There might be some sort of load balancer solution where the clients know to communicate with said load balancer, and the nodes behind that load balancer would know the current leader, and this would be some sort of well-known endpoint, so every node that comes into the network would know who to talk to, as well as they have the full leader schedule. So both the load balancer and the nodes can verify that it is the correct leader that should be receiving all the traffic. One of the other areas that I didn't see clearly explained is how each member knows how much SOL they have. For example, what if a set of malicious nodes appear with high values of SOL vouching for each other and try to join the some good nodes in like a separate network?
Wow, York, you're killing me here. I don't know the answer to that exactly, but I can't imagine that. What I do know is that when a user decides to stake their Solana with a node, it's not available immediately. It's actually available in the next epoch. And same thing with unstaking it. So I imagine what would happen is during that schedule generation process, the nodes would be able to actually check and validate how many SOL is on that node, and do whatever calculations they need to figure out the order. And then afterwards, at that point, users can no longer unstake it and stake a new one. So at least for that specific epoch, you can trust the results. So that's a good engaging discussion. Let's get back to the video. Or the leader schedule. How the order of the nodes are picked using the seed phrase was not described in the white paper or the doc, so we can only assume, but on a high level, this is how it works. So far so good. What Solana does with proof history is that we start with a seed phrase, or not just any starting word, let's say Solana. And we take Solana and then we run it into a hash function to generate, let's say, hash 1. And then with hash 1, the output of our seed phrase, we use it as an input to the same hash function, and we generate another hash value, let's say hash 2. And then we just continue doing that indefinitely.
In terms of SOL, it seems like the proof of history is a great way to generate a local ordering of time-based sequences without relying on a clock. Since there's only one leader who generates the hashes, it'll create a clear sequence of events while that leader is in effect. And this is a great way to avoid having to figure out operations with timestamps and clock skew with all the members that you might not even trust on this network.
Trust. So, can you tell the users, not me, because clearly I know what I'm talking about, what sort of problems? Can you tell them more about the problems with timestamps and clock skews?
Sure. So in a centralized system, there are different transactions which can include a timestamp to help sequence the order of operations of everything that happens in that network. And for those centralized systems, it allows the leader to sequence those operations in a specific order and basically detect discrepancies based on the timestamp. This central system makes all the decisions, so you have to rely on it, and it has all the power and can declare what this truth should be to every single node. In some systems, each machine's time isn't exact with other machines due to differences in delays or hardware, and that means one node could have a different time from another when you ask them for the same time simultaneously. This causes a different timestamp to be added for the transaction, which may confuse the leader for those operations and desired state. And so in order to remedy this clock skew where the times are different, they usually can set up a set of NTP servers. And NTP servers basically are a server that reports solely the current time. And so all the nodes can be configured to talk to the NTP servers, and they can communicate with them periodically to ensure that everybody is on the same time. And with the same time source, they could use timestamps as a source of truth instead of relying on the timestamps on their own machine for uniformity across the network.
Good to know. All right, back to the video. We generate an inner hash value. In order to commit the block, we need to reach something called a supermajority. Essentially, that is when 2/3 of all staked SOL. So in this case, we have a total of 300 SOLs because we have 3 validator nodes, and let's say each validator node has 100 SOLs staked to it. So we need to have a generated final state, let's call final state 1, that has 2/3 of all staked SOL supporting it. So in this case, validator 1 and 2 generate the state final state 1, and combined they have 200 SOL. Now we have this malicious node, validator 3, which generated this final state 2, and it has 100 SOL. So because final state 1 has 2/3, 200 SOL, the majority reached consensus, and this block is saved to the ledger, and then the vote from validator 3 is rejected.
Yeah, so the verification process makes it seem like it's an easier way for people to join the SOL network because it's relatively low cost to come in. But at the same time, if, for example, people have spent a lot of time and energy mining Bitcoin, swap over, won't a lot of their nodes verify more SOL than others and take over?
Yeah, that's one of the great debate over proof of work system like Bitcoin versus a proof of stake system like Solana, Cardano, Ethereum. Specifically, proof of work, you just need enough money to buy all the equipment to start mining to take over the network, versus in proof of stake,
Right.
where you just need to have enough of the coins in this video, or in Solana specifically, you need like 2/3 majority. And the argument for why this works for Solana and other proof of stake systems is that if you own 2/3 of the network at this point, I think it would actually be in your best interest for the blockchain to be actually working and not trying to manipulate it and benefit it for yourself.
Yeah, makes sense.
All right, let's keep going then. Now let's go through another example. Let's say validator 3 actually has 200 SOL instead. I'm a system expert, so there are many people that are much smarter than me, but I do have a bone to pick with the white paper saying that Solana is a CP system. I don't think Solana is a CP architecture. I feel like it's more of an AP. For example, if you were to send Solana to someone else, I could theoretically imagine that while transactions being processed, you can quickly go look at the receiver's balance and see that they haven't received anything. So maybe they have a weaker form of consistency. I don't know, but I feel like saying that it's strongly consistent is not exactly accurate. But
I'd have to disagree with you there. I actually
what?
think that it would be a CP system because this helps secure that the transactions are in fact confirmed by enough nodes that are known by everyone. Here, it's something that you want when you make transactions with Sol. You want to make sure that it isn't already used and has already been transferred to somewhere else. So in terms of like fiat money, when you have like a physical dollar bill and you hand it to somebody and you accept that dollar bill to deliver the goods to the person who handed it to you, you won't want it to have that same dollar bill get handed to some other vendor and have them deliver that goods. You want to accept that dollar before you use that dollar somewhere else. And so it's a little more abstract in the cryptocurrency and like electronic forms, but you want to avoid a potentially split-brain situation where you have the same money get transactioned twice or multiple times, and that's not good for financial record keeping and having to resolve which of those transactions that were processed is correct, because you're not really entirely sure which one's first or which one is the more valid case. And this comes into play, especially if you have more than one leader, then you'd have to distinguish between multiple leaders.
Yeah, I guess that's a good point. I said in the video, I also don't know. I don't know the architecture. So, what do you guys think? And do leave us a comment below because I would love to know the answer to this. But good things to think about. So I guess let's continue. Then again, what do I know? Continuing on. That's what I just said. All right, so each of these leader will continuously generate hashes and use the hash as the input for the next hash. According to the white paper, what each of these leader node does is that every once in a while they'll actually try and synchronize with each other. So how we would synchronize is that let's say leader A would send its current hash, its current state and time, to leader B, which then will hash both that value that it receives along with the hash that it is currently at to generate the next hash, which in this instance, let's say it's just hash 100B. At this point, let's say we send hash 99A. Everything that happened prior to hash 99A has to have occurred before hash 100B. So with this, we have a way to reason about what occurred first. Now, we continue this.
Yeah, so here when we're talking about these multiple leaders, it is pretty easy to say bring up, subsequent leaders B, C, D, E, and F or whatnot. But it's very challenging and complicated to get the coordination between all those leaders to work properly, especially given the potential that you could have malicious leaders. You'd have to figure out among the leaders which ones are valid leaders and which ones are malicious. That's something that would have to be handled by the leaders as well as all the verifiers. The other thing here is, since there aren't like timestamps in like a centralized system, there needs to be some sort of good reasoning between the leaders for different transactions, especially as we had discussed before about the consistency. Like, we would still want to maintain high consistency, but with these different hashes, it's a much harder reasoning that needs to take place in order for that to happen. And so what likely would probably need to happen is some sort of, Raft or Paxos consensus algorithm among these leaders to reach a desired state, as well as take reasoning from Leslie Lamport's time clocks and ordering of events in a distributed system paper for the partial ordering of events, since each leader only knows a subsection of events at a time, and how to reason about that.
Gotcha. Yeah. So I think this is probably like the third time you mentioned Paxos and Raft. And so, we're not going to dive into these topics in this video. But I'm sure York in his Medium post will talk about Paxos, Raft, Lamports, I think Lamport time. And I think you also mentioned vector clocks, or is that something I want you to mention?
That's something you want me to mention.
Okay, well, you all right about vector clocks too? And,
yeah,
his
I
Medium.
can.
Yep, great.
I'll definitely have some articles on Paxos and Raft and some other distributed systems concepts coming out.
Perfect, great. Well, in that case, you the viewers will know where to find them. They'll all be in the description below to York's Medium post. All right, let's continue going through this video then. So let's say hash wanted leader B synchronized with leader C. So if you found this video helpful, I greatly appreciate it if you give it a like, and if you're not subscribed, consider maybe hitting that sub button. But until then, stay tuned for my more regular scheduled content if I ever get that far. Alright, see ya.
Oh, I didn't know you had regular scheduled content.
I do now?
Awesome. I hope to see more stuff then.
I mean, we're making one right now.
Overall, I think from your video, it has definitely a lot of cool ideas from Solana, and hopefully there'll be more stuff from them if slashing of Sol value doesn't keep everyone in cold storage.
Well, that brings up our sponsor to this video. JK, there's no sponsors here. No one wants to sponsor me. Ledger Nano. Ledger allows you to safely stake your Sol from the safety of your cold storage. Also, very important PSA, not your keys, not your crypto. With all the crypto exchanges going bankrupt, I think the latest one being potentially Gemini, please consider moving your crypto to cold storage. But anyways, back to our regular scheduled content. Thank you, York, for taking time to collaborate with me on this video. I appreciate the knowledge that you dropped on us regarding distributed systems, and I appreciate your thoughts on how you thought Solana works based off of, well, this video, how I think Solana works. So if you guys like the stuff that York talked about, mostly distributed systems, do check out York's Medium post, which I will once again link in the description below. And yeah, be sure to check it out and follow and clap his content. Once again, York, thanks for showing up.
Yeah, thanks for inviting me on, Josh. I like the community you've created and all the content you have on crypto. Definitely look forward to both the regularly scheduled content and the future collaborations.
All right, now you're just starting to start a fight, but that's cool. All right. All right, sounds good. Then I'm looking forward to seeing you that article post on vector clocks. All right, then I'll see everyone else later. Bye.